What is electron affinity? Electron affinity is the change in energy that occurs when a neutral atom in gaseous phase gains an electron and releases energy in the process. In simple terms, it is the likelihood of a neutral atom to gain an electron. As we know that an electron carries a negative charge, so when a neutral atom gains an electron, it changes into a negative ion. Since release of energy is an exothermic process, therefore the change in energy has a negative sign, which means that the electron affinity is positive. On basis of this sign convention, we must remember that higher electron affinity indicates stronger capability of an atom to easily accept electrons. Or we can say that an atom with lower electron affinity will not accept electrons as easily. There are two types of electrons affinities we must learn about. First electron affinity and second electron affinity. First electron affinity is the energy released when an electron is added to a neutral atom. And second electron affinity is the energy released when an electron is added to a negative ion. The second electron affinity is positive because more energy is required to add an electron to a negative ion as compared to a neutral atom. For example, first electron affinity of oxygen is minus 142 kilojoules per mole, while second electron affinity is plus 844 kilojoules per mole. As we know that ionization energies are always concerned with the formation of positive ions. Electron affinities are the negative ion equivalent of ionization energy, and their use is almost always confined to elements in groups 16 and 17 of the periodic table. Factors affecting electron affinity. Electron affinity of an element depends on A. Extent of nuclear charge, B. Size of the atom, C. Stability of valence shell, electronic configuration. Effective nuclear charge. Nuclear charge is also synonymous to the atomic number, which is equal to the number of protons present in the nucleus. Protons are positive subatomic particles. Higher the numbers of protons in an atom, the greater is the attractive force applied on electrons and higher is the electron affinity. Atomic size or atomic radius. When the size or radius of an atom increases, the electron entering the outermost orbit is more weakly attracted by the nucleus and the value of electron affinity is lower. That means the electron affinity is higher for smaller atoms. Also, shielding effect is directly proportional to atomic size, and atomic size is inversely proportional to electron affinity. Electronic configuration. Adding electrons to atoms with stable electronic configuration is difficult than adding to atoms with unstable electronic configuration. The stability of the configuration having fully filled orbitals p6, d10, f14 and half-filled orbitals p3, d5, f7 is relatively higher than that of other configurations. Let's look at the periodic trend of electron affinity to clearly understand the effects of these factors. In a period, electron affinity increases from left to right. Exception occurs in case of carbon and nitrogen. Carbon has greater electron affinity than nitrogen because in nitrogen has more stable half-filled valence shell electronic configuration. In a group, electron affinity decreases from top to bottom. Exception to this rule occurs between fluorine and chlorine. Fluorine, due to its smaller size, has high electron density, resulting in a slightly smaller electron affinity than chlorine.
Please like, share and comment on the video, and don't forget to subscribe to our YouTube channel. For more interesting and educational videos to earn while you learn, download Extra Class app from Google Play Store and get rewarded for studying.